This week the students get the Tahoe with the bent exhaust valve all back together and fired up for the first time, so you get to see that, along with some brake work on the same vehicle. These two engines sitting in front of me came out of this Yukon behind me. This engine here was the one that we showed you last week that had that broken connecting rod. And this is the engine we're going to be putting back in the vehicle to replace it with. So you'll see them pull the engine out of the Yukon this week, and then next week we'll start transferring the parts over, connectors and all for the wiring harness, and start putting it back into the vehicle. And finalizing the Tahoe assembly, putting our cooling fan back on tight with our shroud in the air box, a couple of connectors, and then we'll be ready to fire it off.
With the new exhaust valve in and the engine all back together, we're ready for our first startup.
Much smoother than when it came in. Along with the bent valve, we also had a brake problem with the Tahoe. We were pressing the pedal and it was going to the floor, so we clearly had a hydraulic problem. It was quick to see that there was no leaks, so something had to be going on internally with the system. So one afternoon, when the kids weren't here, I did a quick diagnostic on it using pinch pliers. Pinch pliers do resemble locking pliers, but the difference is that the jaws there are no teeth, so that we can crimp the rubber hoses that are part of the brake system and isolate each one of the wheels individually. So what I did is I used the pinch pliers and I crimped off all 4 of the hoses at each corner of the Tahoe, and then was very quick to notice that the pedal was firm, so I knew that there was no internal leaks in the master cylinder. So then I systematically started removing the pinch pliers from the top part of the hose to the bottom and checking for a ballooning of the hose. So after removing the 2 back ones, the pedal was still firm. I took the one off of the left front, moved it down, and the pedal was still pretty firm. As soon as I took it off of the right front hose and moved it to the bottom, the pedal went over halfway down of its travel. So I knew the problem at that point was in the right front. So then I did a little more investigation with it and quickly found out it was not the caliper, so the problem had to be in the hose. So after the students replaced the hose and it was bled out, which you're about to see, we got our brake pedal back. Removing this inner splash shield is going to allow easier access to the brake line. This bleeder screw is full of trash, so we're going to get it cleaned out before we can bleed our caliper. We're using a paper clip to clean out all the trash. We'll take some chemical and blow through it, make sure it's clear. With the bleeder screw clear, in time we can bleed it out, get all the air out of the system, and we'll be ready for a test drive. Here, as you've seen before in other episodes, you can see the air and the fluid passing through the diffuser as we bleed it. I want to show you the hose that the students replaced and what we found with it. If you look at the hose here, you can see that there are ribs running parallel along with the hose. But in this area right here, I don't know if you can make that out. Hopefully you can. There are actually lines running across the hose that way, and that's unusual, and so what caused that was the actual ballooning of the hose. So it got weak in here from over time, just wearing out internally, and the extreme pressure that's inside of it was causing the hose to balloon again just enough that it was causing the pedal to go to the floor. So now I can actually show everyone those ribs and how we can tell just from that the hose was ballooning there, even if we couldn't see it. The new brake line is replaced on the Tahoe, and now we have a good pedal, but we noticed that the pads are worn as well, so we're going to go ahead and replace the pads.
First step is to remove the caliper, get our old pads out of the way, and then we'll begin pushing the pistons back into their bores.
Flush?
With the pistons pushed back, we're cleaning the surfaces of the caliper where they slide. Then we'll put on a layer of anti-seize. Then install the new pads and reinstall the calipers. We also had a tire with a slow leak on our Tahoe. Couldn't find it, so we decided to soak it. You can see little bubbles coming from the wheel where it seats the bead. So what we're going to do is dismount it on that side, clean it up a little bit, and see if we can get it to seal. We'll start by breaking down that back side of the tire. Then we'll take the area that we marked and take some sandpaper and clean it up really well. Then we'll pump it back up, put it back in our dip tank, and see if we've got it. We'll hold it there for a bit, but it's already looking good. We should be able to put this back on the vehicle. One of the holes for the carburetor studs on our engine team engine had stripped out, so we're putting in a thread insert. First step is to over tap it. So he's using a technique of a half turn in and a quarter turn out, and that's to allow the thread chips to fall away so they don't damage our new threads. And after that, we will remove it, and then you'll see that we are left with good threads, but it's oversized to the stud. So this will allow us to put in the insert. Before we do that, we want to blow out the shavings so they don't restrict the insert from going in. The insert's going to get screwed in until it's flush or a little below flush. And then once it's removed, you'll see that we have perfect threads ready for the stud in the original size. The customer has decided he wants the engine replaced in this Yukon, so the students are getting it pulled out, and we'll get the replacement engine prepared and ready to go in. This S10 came to us with a cylinder 5 misfire, so we pulled out the cylinder 5 plug and we'll do a compression test to check it mechanically. What's interesting is another shop said it needed a timing chain, but it didn't seem to have any trouble pulling itself on and off a trailer. So we're going to do this compression test and see how we are. It's got it hooked up. We'll get it cranked, and what you're going to see is that we have over 150 pounds of pressure in the cylinder, so mechanically it's fine. Our next step is to check the ignition system, and you'll see the students do that next week. Next time on Bulldog Builds, we'll get our replacement engine ready to go in for the Yukon, and we'll see if we can figure out our cylinder 5 misfire on that S10. See you next week.